Hi everyone, welcome to this next video. So in this video we're going to talk about functions, we're going to talk about inverse function, we're going to talk about composite functions. This is only for those people sitting a higher paper, and hopefully my method of explaining stuff will make it a little bit easier for you guys to understand what we're doing. Okay, so let's just kind of look at what it is, but effectively this is just telling me that to find this value here I just do this, and to find this value I just do this. It's a bit like equations of graphs. You're just basically completing a substitution. Now, this here, this f of minus 1, is asking you to find the inverse function, okay? So if you ever see the f of minus 1 or g of minus 1, you are finding the inverse function. Now, the way to do this is remove this value here and just change it for y. So that becomes y equals 4x plus 7. So by doing that, we're just differentiating between this left-hand side and this right-hand side of x, okay? I will need to change this y back at the end, but I'll go through the process in a second. So the first thing you do is change that f of x to y. And now, what you need to do now is make x the subject. So by making x the subject, what I need to do is remove everything else that's not on x. So that plus 7 goes over this side, and it becomes y minus 7 is equal to 4x. And then from there, I need to get rid of this 4, so it becomes a divide by 4. So y minus 7 over 4 is equal to x. Now, what I need to do at this point is basically change the y back for an x. So this disappears and we change it back for an x. So it becomes x minus 7 over 4. And then this x disappears and we call it f of minus 1 of x. So all you're doing is you change the initial part for y. You then get x as a subject by moving the other values as you normally would when you rearrange equations. And then from there, at the end step here, you just change this y back for an x. And then the x that you've got on that right-hand side just turns to f of minus 1 of x. Okay? So that's the process of finding the inverse. I'm just going to move that to the side a little bit, so I've got a bit more space. So that becomes your process for finding the inverse function, okay? Now, this next part is a bit different. This is telling you what to substitute in. This is telling you x is now 3. Okay, so when it's inside the brackets, it's telling you that the value of x is 3. So all you do is you go to this function of f, which is this one here, and you change this x value for what is in the brackets. So we now say it's 4 times by my 3 that I brought down plus 7. So 4 times 3 is 12. 12 plus 7 is equal to 19. So you can say f of 3 is equal to 19. Okay? So when it's inside the brackets like that, all it's saying to you is take that value and change it for x. Okay? Last example here is a bit different because now what we've got is we've got a value of x that I don't know, but it has to equal 21. So what I'm saying is f of something, so something, is equal to 21. So when I substitute that x in there, I will end up with 21. So what I can do now is I go back to this equation and I now say 21 is equal to 4x plus 7. So this value of 21 now is replaced by that because we're saying f of x is equal to 21. So that goes there. And now you need to find the value of x. Well, this is now just a case of rearranging. So the plus 7 goes over that side and it becomes 21 minus 7 is equal to 4x. So 21 minus 7 is 14. So 14 is equal to 4x. And then to get rid of that 4, you divide by 4. So you're saying 14 divided by 4 is equal to x. Now, you can leave it like that, or you could say 4 goes into 14 3 times. So x is equal to 3, 4, 8, 12. And then 2 out of 4 left over, or 3.5. Okay, so for the function of f to equal 21, x has to be equal to 3.5 or 3.5. Okay, what you can do now is you can have a go at these three. So what I've got now is a g of minus 1. So this is your inverse function of g. So follow the steps I did here. Don't forget there's a squared in this one, so your last step will probably be a square root. Here, using 7, substitute into there. And then this one, we're saying 67 is equal to that. So pause the video if you want to, have a go at that. And then I will go through it now. Okay, so this first one, we are saying y is equal to x squared plus 3. So then y minus 3, because I'm taking that plus 3 over there, is equal to x squared. And then to get rid of the squared part, you are just square rooting y minus 3 is equal to x. So that is the inverse function of g. Second part, now all I'm doing, now all I'm doing is I'm taking this value of 7 and changing it up here for x. So I'm going to say 7 squared plus 3, well 7 squared is 49, 49 plus 3 is 52. So g of 7 is equal to 52. And the final one here, I say the answer is 67, so 67 is equal to x squared plus 3. Rearrange this, I want to find x, so the plus 3 goes over this side, and it becomes a minus 3. So we're saying 67 minus 3 is equal to x squared. 67 minus 3 is 64, is equal to x squared, and the opposite of squared is square root. So you square root 64 gives you x, which is 8. So x is equal to 8. Okay, that's your inverse and normal functions, just how to substitute in. Let's now talk about how we do composite functions. So that's your inverse functions and functions when you substitute in. We now need to talk about composite functions, and we're also going to talk about composite functions with quadratics as well. Okay, so we've got an example here where we've got two different functions. So f of x is equal to 5x plus 2 over 3, and then g of x is equal to x squared plus 12. Now this is a composite function here. So what we're saying is we have a function of f, but we also have a function of g combined. So this is like writing it as g of f of 5. Now when you see something like this, what you basically need to think to yourself is, let's ignore the g for a minute and deal with the f of 5 first. So I'm going to do this bit first, and once I've got my answer for that bit, I will then end up doing the g of that. So we're going to do the purple bit first here. So I'm going to do f of 5. So this goes back to what we were doing previously. I take 5 and I basically substitute it in there. So I'm saying 5 times by 5, because remember 5x here means 5 times whatever x is, and we're saying x is equal to 5, plus 2 all divided by 3. So that gives me 25 plus 2 divided by 3, so 27 divided by 3, so that is 9. So that first part, f of 5, is equal to 9. What you now do is you take that answer of 9 and you substitute it into your g1. So you're now saying x is equal to 9. And because this is the function we're now using, we then say 9 squared, because it's x squared is the first part, then plus 12. Well, 9 squared is 81. 81 plus 12, 93. So we can say that g of f of 5 is equal to 93. Okay, so first thing you do the f of 5 first of all. So substitute that 5 into this bit, which is what we've done in purple here. Once we've got our answer, we then use that new value of 9 and substitute it into the second function. You do this bit last and you do this bit first. Okay, so let's now look at what happens on this right hand side when we've got g of f of x. Now what we've basically got here is a function still. It's still a compound function or a composite function, but we're saying we're going to have to do f of x first. And once we've got that answer of f of x, we then need to substitute that into g. So this is a little bit harder. I'm just going to move this out of the way to get a bit more space. This is a little bit harder now, but the concept is still the same. You are going to do f of x first. Well, I know that f of x is actually this function. So f of x is equal to 5x plus 2 over 3. So that purple bit that I would normally do first, like I did here, the f of 5, is just the same thing. So f of x is this. What you now do is you take that f of x and you substitute that into that x squared. So I'm taking this whole value of 5x plus 2 over 3 and changing x for that. Now, because it's x squared, it means multiplied by itself. What I did down here was I took my 9 and squared it. I'm now taking this and squaring it. So I say 5x plus 2 over 3 all squared, which means I times it by itself. So that is now that bit, then plus 12. Okay, let me just recap what I've done. So the f of x is what I'm substituting in first. Well, f of x is actually this whole thing. So you take that whole thing and you change this value of g in the g function, this value of x, for that whole thing. So take that, put it in there, but because it's squared, it means I times it by itself. What you now do is you basically expand this. Now, this is effectively like me multiplying a fraction against a fraction. So top times top, bottom times bottom. But because you're multiplying two parts, you're doing 5x times 5x and then 5x times 2. So that gives you 10x squared, 25x squared plus 10x. Then you're doing 2 times 5, again, which is your 10x, and then your 2 times 2, which is 4, all over 9, because 3 times 3 is 9. And then we've got this plus 12. Now, I can't just add 12, because what we're looking at in this question is this is now a fraction. So let's tidy that up first of all to make it a little bit easier to work with. That becomes 25x squared plus 20x plus 4 over 9 plus 12. We turn that to 12 over 1. And because we are now multiplying with adding with fractions, I need to make the denominators the same. So I'd have to times that whole part by 9 to make 9 at the bottom. So that would become 108. So 9 times by 12 is 108 over 9. And from there, so I can remove that now. From there, you're now working out what this becomes, which is 25x squared plus 20x, and then 4 plus 108 we can now do, which is plus 112 all over 9. And that would be my answer to g of f of x is equal to that there. Okay, so a little bit of a harder one because there's a fraction involved, but the first thing you do is work out f of x. Well, f of x in this case is that. That now goes into here, so by doing that all you do is multiply it by itself. When you're expanding this, you expand top by top. Use your moon method there to expand that out, bottom by bottom, and you end up with that. Okay, tidy all that up. This bit at the end is a little bit harder because there's a 12, you turn it to 12 over 1 because you're working with fractions, then you've got to make the denominator the same, and then you work out the top, and it's all over 9. Okay, so last bit we're going to look at here now is where we have two functions, but we have two composite functions that we're going to combine. So in this bit here, what I do is I work out the composite part here first of all. So I work out g of x, and then once I've got that, I substitute that into the f of x. So it's the same as what we've just done. Have a go to see if you can work out that left-hand side if you want to, first of all. Pause the video and have a go. And also do the same here. So do this first of all, and then once you've got that, substitute that into there, and then set up an equation. See if you can do that bit first. Pause the video, have a go, and then I'll explain what happens. So let's do that first bit. So I do g of x first of all, which is just x squared. And then I'm taking that x squared. So g of x is x squared. And now I take that x squared and put it in there. So it becomes 3x squared plus 1. So g of x is x squared. I take that x squared, put it in here, and replace that that 3x for x squared, then plus your 1. Then look at the right hand side now. So f of x is equal to 3x plus 1. And then I'm taking that 3x plus 1 and now replacing it there, because remember we've got to do the f of x first, which is that, and then substitute into g, which means all I do is 3x plus 1, 3x plus 1 because it's just squared. That gives me 9x squared plus 3x plus 3x plus 1, which is 9x squared plus 6x plus 1. So I can put equals 9x squared plus 6x plus 1. So I've now created an equation. Now if I want to solve this, this is a quadratic. Therefore, in order to solve it, it has to equal 0. So I'm going to take all of this and take it over this side, which means it now becomes 0 is equal to 9x squared plus 6x plus 1 minus 3x squared minus 1. Remember, when you're moving something over an equal sign, the signs change. That positives turn to a negative, that positive turns to a negative. Now from here, I just need to tidy that up. 9x squared minus 3x squared is 6x squared. 6x, there's nothing else to tidy that up with, so it stays as 6x. And 1 minus 1 is just 0. So I'm saying 0 is equal to 6x squared plus 6x. You now need to factorise this to be able to solve it. Well, what value is in both of those? 6x. How do I get 6x to 6x squared? I times it by x. How do I get 6x to 6x? I times it by 1. So that's now factorised. It looks slightly different to a normal quadratic, because in a normal quadratic we'd have two brackets with two values in it, so it'd be an x plus 1 and a 6x plus 2, for example. But if you ever have a situation like this where you've got a value on the outside of the brackets and then a value on the inside of the brackets like that, we can basically say that 6x, the outside part, is equal to 0, or the inside part, x plus 1, is equal to 0. Then you solve it from here. So we say x is equal to 0 divided by 6. Well, 0 divided by 6 is 0. So x is equal to 0 as one solution. Or take your plus 1, take it over the other side, x is equal to minus 1. So these would be my two solutions to this question. Okay, so it's a composite function where you have a composite function there, but you also have a composite function on this side where they both equal each other, gives you a quadratic, make it equal 0, because remember, to solve a quadratic it must equal 0, factorise it, solve it from there. Okay, have a go at this last one here if you want to. So pause the video, have a go, and I will go through it in a second. Okay, here we go. So g of x, first of all, is that. So I take that value of x squared plus 6, and I now change x for that. So the left-hand side becomes x squared plus 6 plus 7 is equal to, and then I work out this right-hand side, f of x is x plus 7. So I take that x plus 7, and I now substitute this x squared for x plus 7, so it becomes x plus 7 all squared, so multiply it by itself, and then the plus 6 stays there. Expand this out, x squared plus 7x plus 7x plus 49 plus 6, because I've still got that bit in the end. Tidy this up, x squared plus 14x plus 49 plus 6, so x squared plus 14x plus 55. So this right-hand side becomes x squared plus 14x plus 55. So I've set up an equation now. Let's now look and see what we can do to tidy this up. Well, if I was to take the x squared over here, it would become a minus x squared, which means these two would cancel each other out. The 6 and 7 ends up giving me 13. So I end up with 13 there is equal to 14x plus 55. And now I basically need to get x on its own. So this plus 55 goes over there and becomes a minus 55. So we've got 13 minus 55 is equal to 14x. Well, from here, you just need to isolate your x. So you're doing 13 minus 55 on that left-hand side, which gives you minus 42 is equal to 14x. And then from there, 14x goes over, divide by 14. So minus 42 divided by 14 gives you minus 3. So x is equal to minus 3. Okay? So that's your compound functions. Composite functions, you might hear them called as well. The same thing, compound composite. Using algebra in this situation here is a little bit harder because you're trying to solve it. If we go back to this one as well, same thing, we're trying to solve it. That one's a quadratic, so whereas this one here, there's no x squared value because they cancel each other out. This is a normal equation you can solve with just isolating x. This one ends up giving you a quadratic, so you have to factorise it, making it equal 0. And in these examples here, compound functions or composite functions, when you've got a value, substituting the value first of all, and then work out from there. Hope you found that useful. It's quite a complicated topic, but if you practice it and get your head around it, you can pick up quite a lot of marks just from starting your process in the exams with it. Okay, hope you found it useful, and I'll see you all in the next video.